functions. We never have to worry about them. Awesome. So what type of function is this? Identifying the function correctly would give us the correct domain. So here we identify the function correctly. It was, where is it? I don't have my pages in order. So here we identified it correctly. It was a square root. We know that the quantity under the square root has to be greater than or equal to 0. We stated that restriction. We solved it. And this interval, this inequality changes into this interval. And this gives us the domain. Now, here we identified it was a polynomial function. No problems. So here we have x minus 1 over x squared minus 25. What type of function is this?
It's not a quadratic
No.
function, is it?
No. This is quadratic. Quadratic functions cannot have a domain, a denominator with x, with a variable in it. So what type of function is this? We wrote this a few minutes ago. So what type of function is it?
It's a rational.
Very good. What could the problem be here? What problem we could run into here?
I can't equal 0.
What cannot equal 0?
X.
No.
The denominator.
The denominator, I completely agree. Always the denominator. The numerator is no problem ever. The denominator could be the problem. Good. How do I solve this equation? Can anyone factor this for us?
X plus 5, x minus 5.
Very good. Awesome. So then what are the two options here that x cannot be?
Negative 5 and 5.
Awesome. Thank you so much. How do I write the domain? In interval notation.
Negative infinity, comma negative 5, a union.
I have to start at negative 5.
Infinity. 5. And then the union.
I have to start at 5.
And then another infinity.
Excellent. So in plain English, this says this. Anything you want except these two. Why? Because division by 0 is called division by 0 is a fancy word. Fancy. It really means it does not exist. But we prefer a fancy word. Anyone remembers that fancy word? Yes. That's why when we encounter a rational function, we have to make sure that this is never 0. Awesome. Okay, finally, before we move on, here is a word problem. Incidence of breast cancer. The following graph approximates the incidence of breast cancer per 100,000 women as function of age, x in years. The equation for this graph is given, and the graph is given. Use the graph to estimate the domain of I of x. Can anyone give us the domain of I of x? domain. So this is 63. Can
Is it
anyone?
25?
Yes, it appears from 25 to,
I'd say like 102 something.
yep, I agree with 102 as well. Perfect. But because points exist, I had to use brackets from 25 to 102. Awesome. Going back. Use the graph to estimate the range. Can anyone give us the range? The range for this graph. From the lowest y value to the highest y value.
0 to 500.
0 to, I would say 450. Would you agree with 450?
Okay, yes.
Perfect. Final question. What 10-year age interval sees the greatest increase in the incidence of breast cancer? What 10-year age interval sees the greatest increase? If they're asking us about the peak, I would say somewhere between 75 and 85. But they're asking us greatest increase. So the increase is slow, higher, higher, the highest, and then the increase starts decreasing. So let me explain this, because this is what we are going to deal with in this class. Rate of change, increase. So roughly this is the graph. From 25 to 100. See, the slope here of the tangent line is this. The slope here is this. The slope here is this. The slope here is this. And then this, and then this, and then this, and then this, and then decreases. See, this, let me see if I have something smaller. Okay. So this rate of change, this slope, is not as steep. I can walk on it, nice and easy. It gets a little bit more difficult for me to hike at 30-degree angle. At 45, it's even more difficult. A faster increase. Even faster. More difficult to go up. Okay, it's smoothened out. So it's slower. Oh, this is the easiest to walk on. And again, now it's decreasing. So this area, is with the fastest increase. The fastest increase is right here. This is increase, yeah. This is okay. Oh, now this is difficult. Oh, okay. Less increase. Oh, no increase at all. And decreases in number. Decreases in rate of change. Decreases. So this is the area with the fastest increase. Okay, any questions? Any questions?
So what's the answer?
Oh, sorry. Thank you. So The fastest increase, I would say, for 10 years, it appears to me very difficult to read from the graph, right? But I would say between 50 and 60. This is less increase, and here is, yeah, it's the highest number if you want, but the fastest increase. Okay, increase means rate of change. Okay, so I would say between 50 and 60, the number increases the fastest. And then it starts decreasing after 70 to 80 or 75 to 85, where it reaches the peak, the highest number, but not the highest increase. At this point, it's not increasing in number. It reached the peak, and then it starts decreasing. Good. Okay, moving on. Now, slope and linear functions, let's quickly review this. So that's R.4 lines. Okay, so we already graphed, reviewed with x and y intercepts. So we have lines that have a positive slope. Slope is positive. Here, slope is negative. Here, very nice and easy, slope is 0. And for the vertical lines, undefined. Increasing from left to right, positive slope, decreasing, negative slope. Horizontal lines have slope 0, vertical lines have the slope undefined. We do know that this definition of the slope, can anyone remind us the definition of the slope?
Yx plus b.
So it's y2 minus y1 over x2 minus x1. And y equals mx plus b. Mx plus b is the slope intercept form. And we do have the y minus y1 equals the slope times x minus x1, which is the point slope form. Slope intercept form and point slope form. Now, two lines are parallel. Anyone remembers parallel lines? What is the slope? M1 and M2. What is the relationship between M1 and M2 if the two lines are parallel? Anyone remembers? If two lines are parallel, the two slopes must be anyone?
The same.
Yes, perfect. What about perpendicular? Perpendicular lines. So a line perpendicular to another. 90-degree angles, 4 of them. 4 90-degree angles. So this is line with slope M1, and this is line with slope M2. What is the relationship between the two slopes if the two lines are perpendicular? Anyone remembers? The way I like to remember it is the product equals -1. I'm sure you were taught to say M1 equals -1 over M2. One slope is the multiplicative inverse, the negative multiplicative inverse of the other. So much easier. Cross multiply. Product is -1. It doesn't matter which one you remember, it's the same thing. Okay, so let's take a look and see what we want to do, because then I would like to talk about average rate of change. Um, it's just easier to go back. Okay. So these are all linear functions or expressions that we have to determine something about. So let's see. Profit and loss analysis. Let me know what you are interested in. Highway tolls. I think we are okay with graphing, so maybe we should just move on and determine the equations. We're given 2 points. We're asked to find the equation of the line. So would you like to start with that, or that is too easy and you remember that, so we don't have to worry about it? Please tell me whether, given 2 points, do we know how to determine the equation of the line?
Can we do it real quick?
Yes, please choose.